Okay, these are the topic 4 lesson 2 notes. Plate tectonics and Earth's surface, pages 166 to 174. This is for Earth science. Please follow along in the book. If you need to pause these and go over them or catch up on notes or go over them again, you're more than welcome to. This first slide, you do not need to write these guiding questions down, but this is what we're going to be learning this lesson. How do Earth's plates move? How do Earth's surface features support the theory of plate tectonics? And what are the products of plate movement at different scales? So the theory of plate tectonics, this is summarized. This is not straight out of the book. I just kind of summarized what was in the book so that you understood what the theory of plate tectonics is. So the theory states that the Earth's lithosphere is broken up into distinct plates. These plates are in slow, constant motion. The plates meet at different types of boundaries, and there are different events and features that occur at their boundaries. What drives plate motion? So what drives plate tectonics or plate motion? Convection currents drive the movement of tectonic plates. Who can describe convection currents? Yes, the hot magma rises. As it rises, it begins to cool. When it cools, it sinks and then starts to heat up again. The process continuously repeats. So this is the process that actually moves the plates around. Types of crust, this should be fairly easy. What are the two types of crust? Oceanic, of course, found at the bottom of the ocean, and continental. Plate motions over time. How much do plates move per year? They move 1 to 10 centimeters per year. Now, the problem with that is we don't really know centimeters too much in the United States. So, if you could look this up on Google quickly, convert 1 to 10 centimeters to inches per year so that you can find out how many inches that is, okay? So, roughly, it moves 0.39 to 3.94 inches per year. So plate motions over time, still continuing on that. When did Pangea form? 250 to 350 million years ago. When did it start to break apart? About 200 million years ago. So here is Pangea, and again it formed 250 to 350 million years ago. It started to break apart 200 million years ago. Tectonic plates and the ring of fire. Where do most earthquakes and volcanoes occur? They occur at plate boundaries. What? Oh. What is the ring of fire? It is a region around the Pacific Ocean that is prone to volcanic activity and earthquakes. So this is what the ring of fire looks like. Plate boundaries. What are the three types of plate boundaries? And this is the basis in this lesson. This is really kind of what we need to go over. Okay, so the three types of plate boundaries are divergent, convergent, and transform. Divergent boundaries. What are features of divergent boundaries? Two main features of divergent boundaries are mid-ocean ridges and rift valleys. How do divergent boundaries move? They move away from each other. So here's an illustration of what divergent boundaries look like. As it said, the plates are moving away from each other. Convergent boundaries. What is a convergent boundary? It is where two plates collide. In other words, they move toward each other. What happens if two continents collide? A mountain range is pushed up. What happens if one or both of the plates are oceanic? And then we have what is called subduction occurs. All right, so picture of a convergent boundary where two continental plates collide pushes up a mountain range. Okay, picture of what happens if one or both of the plates are oceanic. So you can see the ocean. So this is subduction. This is pushed down. Okay, and notice this part doesn't go up. This is just pushed down. Then we have transform boundaries. What do plates do at transform boundaries? They slide past each other. Earthquakes are very common at transform boundaries. So this is what a transform boundary looks like. One plate is going one way, one is going the other. So in review, we have divergent boundaries that are moving apart. We have convergent boundaries that are coming together or converging. And we have a transform boundary where they are sliding past each other. And those are your notes for Topic 4, Lesson 2, Plate Tectonics and Earth's Surface for Earth Science.